Hi all, welcome to the course Computational Linear Algebra. This course is offered through the RSET MOOC platform and is designed to build strong foundations and computational methods used in modern linear algebra. So first of all, we will have a course overview. So what you will get after this course? So this course mainly introduces computational and numerical aspects of linear algebra, and it always focuses on metric computations used in engineering and data science, emphasizes algorithms, numerical stability, and conditioning, connects theory with real world applications. And in this course, we mainly deal with MATLAB and covers key topics like linear systems, eigenvalues, SVD, and least squares, and builds foundation for data analysis, machine learning, and scientific computing. So first of all, let me introduce myself. My name is Agnes Jonsabu, and I'm from the Department of Mathematics. I'm actually a postgraduate graduate in mathematics with my academics background from Alfonso College and SS College Devara. So, so here we are moving to our first module, that is fundamentals of matrices and computation. So what are we dealing in this module? So first of all, the key topics we are discussing here is, first we will have a introduction on matrices, vectors, and linear equations, which you have already studied in your smaller grades. And we will also look mainly to the metric operations and properties. We will also study what is Gaussian elimination, how we are applying that. And we will also study LU decomposition, numerical stability, and conditioning. And after this module, in last of this module, we will study to solve linear systems and verify the solution using MATLAB. And what you will get after this module. So you will understand the structural properties of matrices. You will be perform efficient metric computations, solve linear systems using MATLAB, and verify solutions and understand numerical errors. So we are starting our module. First, we will have an overview of matrix. So what is a matrix? As we all know that matrix is a rectangular arrangement of numbers arranged in rows and columns. So here I have an example of matrix. Here you can see. So it is actually a rectangular arrangement of rows and columns. So this is rows. So in this matrix, you have 1, 2, 3, 4 rows, and you have 1, 2, 3, 4, 5 columns. Okay. So this rectangular arrangement is called a matrix. So we will always notate a matrix like A equal to in a square bracket Aij. So what is Aij? Aij represents the element in the ith row and jth column of the matrix. So next we will look what is order or dimension. Order is actually the number of rows. M is actually the number of rows and N is actually the number of columns. So we call it as M by N. So if a matrix has m rows and n columns, we will call it a m by n matrix. So here you can see, as we already seen, that it has 4 rows and 5 columns. So this is actually a 4 by 5 matrix. Hope you are clear with that. So in the next slide, we will look what are the types of matrices. So the first 3 types are based on the dimensions. So we have already seen what is a dimension or what is a order. It is also called order. So when we speak about dimension, the matrix can be 1 by n matrix. That is, it has only 1 row and it has n columns. It can have n number of columns. So here there is an example, that is 1, 8 minus 4. This is actually a 1 by 3 matrix, right? It has 1 row and 3 columns. So this type of matrices are called raw matrix. Okay, this type of matrices are called raw matrix. That is a matrix with only 1. So next type is a column matrix. It is similar as we said, that is, it's the opposite. It have n number of rows and it have only 1 column. So here there is example, is a matrix 9 minus 3, 6. So it is a 3 by 1 matrix, right? So a matrix with only 1 column is called a column matrix. And next, one of the most important metrics is square metrics. So in this chapter, we are focusing mainly on square metrics, especially 3 by 3 metrics. So what is a square metric? Square metric is actually a n by n matrix. That is, the number of rows is equal to the number of columns. That is, here there is example. That is, it has two rows. That is 1, 2, 3, 6 are 2 rows, and it have 2 columns. So it is a 2 by 2 matrix. So it is a square matrix. So what is a square matrix? The number of rows and number of columns are equal. Okay, yes, we are moving to next slide. And next is also the type of matrix. So it is special form. It depends. So the last slide, which depends on dimension. So in this slide, we have a special forms. The first one is the zero matrix. That is all entries. It is not, they are not mentioning about dimension. Dimension does not matter here. So here the thing is, all the entries, all the elements in a matrix will be zero. All entries are zero, and we also denote it as O. That is, we can also denote a zero matrix with the letter O. And here you can see that these two examples are zero matrix, examples of zero matrix. And next we move to diagonal matrix. So diagonal matrix, what is the specialty of a diagonal matrix? So first of all, it should be a square matrix. Okay, so the diagonal matrix, first of all, it should be a square matrix and non-zero elements only on the main diagonal. So if you see this example, you can clearly understand that the elements which are non-zero are only on the diagonal. That is 2, 8, minus 5 are non-zero numbers. So they are only in the diagonal. And the other members, other elements are zero. So this type of matrices, we call it as a diagonal matrix. So the next one is identity matrix. So identity matrix, we always represent this with the letter I. So the first thing is it should be a square matrix, and it is also a diagonal matrix, but the only thing is the diagonal elements are all 1. So here you can say it's a 3 by 3 matrix, and the diagonal elements are 1, 1, 1, the other members are 0. So this is an example of identity matrix. And next we are dealing with basic metric operations. We are already familiar with this, but we can discuss that here. We will discuss each operation with an example. So first operation that we are dealing is addition, and we can also say subtraction with that itself. So how we can add two matrices? If we get two matrices, how can we add, or how we are doing this addition and subtraction? So here we are adding it by element ways. That is, the sum or difference or the subtraction is obtained by adding or subtracting corresponding elements. That is, for example, here there are two matrix, you can see matrix A and matrix B. So we are taking the first element of the matrix A and we are adding it to the first element of matrix B. Okay, then if you are taking the second element, we are adding the second element to the second element of the matrix B. So that is, we are corresponding elements are added or subtracted here. So the first example, if you look, we are taking two matrix A and B. So what is A plus B? A plus B, it is written that that is 2 plus, what is the first element of B here? Minus 5. It is 2 plus minus 5. You can see it is minus 3. And minus 9 plus minus 9, that is minus 18, the second element. And the third element is root 5 plus 3 root 5. You can say it is 4 root 5. And the fourth element is 5 plus 6, that is 11. Like that, we can add two matrices. The subtraction is also in the similar way. We are subtracting the corresponding elements. That is 2 minus minus 5, that is 2 plus 5, that is 7. And minus 9 minus minus 9, that is minus 9 plus 9. That is actually we are getting 0 here. And like that, we are continuing. So we will get the addition and the matrix obtained by adding and subtracting two matrices here. So hope you understand what is addition and subtraction of a matrix. It is very easy. We are just adding or subtracting the corresponding elements of two matrices. The next basic metric operation is the scalar multiplication. So here it is not, we are not multiplying two metrics, we are multiplying a scalar k. The scalar can be a number or any constant like that. So we are so it have only magnitude. That's why we call it as a scalar. So k, let k be a scalar. And what is k multiplied to a matrix A? So the product of this will be, we will be multiplying this k with each element of matrix A by k. That is, for example, we have example here, example A with the matrix 5, 5, 8, minus 10, 7, 4. And we are multiplying a scalar. So I'm taking k as 3 here. So 3, what is 3 multiplied to A here? We are multiplying this 3 to each element, that is 3 into 15, 3 into 5, that is 15, 3 into 5, 15, and 3 into 8, 24, like that. We are multiplying this scalar to each element of A. So it is very simple. That scalar multiplication is very simple. We are just multiplying the scalar to each element of the matrix given. So the next very important matrix operation is the transpose of a matrix. So what is a transpose of a matrix? So before studying what is transpose, you should be able to identify the number of rows and number of columns. That is the matrix obtained by interchanging the rows and columns. So if we get a matrix A here, we can see by an example, we have a matrix A here. So it is actually a 3 by 2 matrix, right? It has 3 rows and 2 columns. So it is 3 by 2 matrix. And what is A transpose? A transpose is denoted as A dash. You can use A dash, or it is mainly denoted as A raised to T. Okay. By using this notation, we mainly represent transpose of a matrix. So what is A transpose? A transpose will be, if the matrix is a 3 by 2 matrix, the A transpose will be a 2 by 3 matrix, right? So here you can see that it is a 2 by 3 matrix. And we are changing, this is the first column, and we are changing that column into row. That is 2 root 5 0 is actually row here, and the second column to the second row. That is meant by the matrix obtained by interchanging the rows and columns. We are making the rows to columns, and we are transforming this column to a row, like that. Okay, hope you understand this metric operation. So this is the last operation we are discussing. So that is metric multiplication. Okay, this is very important. Now, metric multiplication is very important, and it is quite confusing too, but we can learn that. So what is a matrix multiplication? We are multiplying two metrics. Okay, that is. So the main rule you can remember it by this rule: row by column matrix. Row by column rule. I will say what it is. That is the first condition. So the matrix multiplication is quite complicated. The first condition is that if you are taking a matrix A and we are taking a matrix B, so A cross B, if you are multiplying A to B, the number of columns of A must be equal to the number of rows in B. That is the first condition you should look. So whenever you are getting two matrix, first you have to check whether the number of columns of matrix A, whether it is equal to the number of rows of B. Okay, so the matrix multiplication goes by this. So A is a matrix Aij, and we can say that it is a M by N matrix, and B is a, let it be a matrix B JK, and it is a N by P matrix. So here you can see that the number of column of matrix A is N and matrix B is N, the number of rows is N. So you can say that they both are equal, right? The number of column and number of row in the second matrix, they are both equal. So we want that type of matrix to be multiplied. So what is AB? A cross B is nothing but it is a matrix CIK. I have denoted it as CIK. That is, we multiply the ith row of A to the kth column of B. Okay, by looking at example, you will understand that, but just try to understand the definition. So if we take the ith row of A, we multiply that with the other column, that is the kth column of matrix B. multiply them element wise, and we multiply, and actually we take the sum of this and take the sum of all these products. So the first thing you have to understand is the same thing, that is m by n cross a n by p matrix. What will be the resulting matrix? The resulting matrix will be a m by p matrix. Okay, so that the n that n will get cancelled and not cancelled. The operation is like this: m by p matrix. So the resulting matrix is actually m by p matrix. So there is an example provided here. So for example, you can see that I'm taking two matrix A and B. So here you can, by seeing it, so we can understand that A is a 2 by 2 matrix, right? And B is that there is 2 rows and 3 columns. So it is a 2 by 3 matrix. Okay, so 2 by 2 matrix cross 2 by 3 matrix. So the first condition is okay here, that is the number of columns of A is equal to the number of rows of B. So what will be the resulting matrix? So 2 by 2, 2 by 2 matrix cross 2 by 3 matrix. The resulting matrix will be a 2 by 3 matrix. You can see here the result is a 2 by 3 matrix. And we can study how to multiply that. That is, we are taking the first row. Okay, so here ith row, that is, I am taking the first row and the first column. Okay, so here you can see that the first element is 2 in the first column. The first element is 2, and the second element is 4. And kth row means here it is the first column itself, that is 1 and 8. So here you can see that is 2 into 1 plus 4 into 8. So the procedure goes like this: 2 into 1 plus 4 into 8. So that is the first element of the product matrix. And what is the second element? Second element is the similar way. We are multiplying the same row with the second column, that is the kth column. Second, here it is the second column, that is 2 into 4 plus 4 into 1. And the third element is first row, that is 2, 4 into the third column, that is 2 into 2 plus 4 into 2. So we got the first three elements, that is the resulting will be 34, 12 and 12. And the fourth element, the similar way, we are taking the second row. Okay, so here we are taking the second row and the first column, that is 5 into 1 plus 3 into 8. Okay, that is 5 into 1 plus 3 into 8, that is 29. And what is the next element? Next element, the same row multiplied to the second column. So we are considering the second column. That is actually, I have said the row by column. We are taking the row and next we are taking the column. And the next element is 5 into 4 plus 3 into 1. And the next element will be 5 into 2 plus 3 into 2. So the answer is 29, 23 and 16. So this is the resulting matrix. I hope you are clear with metric multiplication. So just remember this rule, row by column matrix. We will take the corresponding row and we will multiply each row and take the sum with each column like this. Okay. The next thing we are going to discuss, what is a vector. So here we are just telling what is a vector. In the coming modules, the module 2 and in module 3, you are dealing mainly with vectors. So you will understand deeply on that time. So here I have just some definition, some basic definition in one slide. What is a vector? So vector, what is a vector? In formal linear algebra, a vector is simply any element of a vector space. So we will deal what is a vector space in our coming modules. So if you consider a vector space, the element of a vector space is called a vector. So there are some things that a vector should satisfy, that is u plus v belongs to capital V, that is vector space. And when we multiply it is closure under scalar multiplication. That is, if you multiply a scalar to a vector, that element will be belongs to vector space. And we all know what are the 8 axioms: associativity, commutativity, existence of zero, existence of inverse, something extra. So here I have just provided just introduction. We will deal this in our coming modules. We will deal in detail about what is the vector. So we can so we can stop this section here and we will continue the main things. This is actually introduction to what is matrix and what is vector. So in the coming sections, we will deal what is LU decomposition and what is Gauss elimination. The coming section, we will deal what is this, and we will also do problems of this. Okay, thank you.